just if I don't put it over here, I'll forget to say anything about it. So. You guys will need a blank sheet of paper here shortly, so if you want to go ahead and just get that out and sorted. Also, as I told you yesterday, I would like your 110 synthetic long division practice we did yesterday turned in. So if you did not put that in Google Classroom, please come put it in the basket before we get started here. So we did long synthetic division yesterday because I had mentioned that was going to come up in all three of the last big sections we're going to do, 2.5, 2.6, and 2.7. So today we're actually moving into 2.5. And it has a lot to do with the fundamental theorem of algebra. So we're going to go through this worksheet together as some practice, some notes, and then we'll go over part of the book assignment together because the book assignment does have something on there that the notes did not have that I guess you guys didn't do in Algebra 2 last year, but normally you do. So that's fine. It's just I need to go over a little bit more of it than I normally do. Okay, so section 2.5 really focuses around the fundamental theorem of algebra, which again, you may not know what the fundamental theorem of algebra is, but when I say it, I bet you probably know what it is. And the fundamental theorem of algebra says that the degree of a polynomial is the same as how many zeros it has, or how many solutions it has, same thing. So quadratic has two solutions, or two zeros. Third degree would have 3 zeros. 10th degree would have 10 zeros. Now, some of those zeros might be real numbers, some of them might be imaginary numbers, but in total, whatever the degree of the polynomial is, tells us the number of solutions or zeros that it has. So, to start off here, we kind of start off with the review question because this is a quadratic, and to find its zeros, the reason why it's called zeros is because you're interested in where it equals 0. And of course, when it factors, that's a little bit quicker, so we prefer to do that. But this one unfortunately doesn't. So, like we've been doing recently, and we'll need to do a couple times today, we will need to use quadratic formula. So, as we talked about a week or two ago, you have to have it memorized correctly. I'd say the most common part of that that's wrong is this b. Sometimes y'all make it positive b instead of the opposite of b. You need to know where a, b, and c come from and plug them in correctly. You need to be careful with the discriminant arithmetic. And if the radical broke down, we broke down the radical. Looks like 60 is 2 times 15. 2 square root of 15. And then finally, not every time, but sometimes, if all of the terms are evenly divisible by the same thing, we should do that. So let's divide this by 2, divide this by 2, and divide this by 2. But of course, anything over 1, we don't have to put it over 1. So quadratic, we should have 2 solutions, and there they both are. Now, the reason why it's starting with this is going to be kind of a common theme. I don't know that any of the other questions we have today start off as quadratics, but a lot of our questions we are going to break them down into quadratics. And as much as you may not like quadratic formula, it at least, if we can get it down to a quadratic, we at least know that we have a method to be able to finish the questions. So, question 2 is a 4th degree, so it should have 4 zeros. And so, I didn't make this one up, but I would make 4 blanks. I kind of like to know what I'm aiming for at the beginning because it helps me catch some of my mistakes. Now, just so you guys know, just like there's a quadratic equation, there's actually a cubic equation that can solve cubic equations and a quartic equation that can solve quartic equations, but they are very complex and probably nothing that you'd ever have to see. But they do technically exist, but they're not really worth the effort. Now, how we're going to solve these kind of depends. It depends on if it factors, it depends on if we give you a calculator, and it depends on if we give you a hint to start off with. So the couple that we have on this side, we're going to say no calculator and no hint, which means that it would need to factor. So this is the difference of 2 squares. If something factors more than once, you really want to factor it again. You had another difference of 2 squares. And solving where that equals 0 is nice, of course, because we can set this equal to 0 and solve quickly. Set this equal to 0 and solve quickly. But there's 2 more answers. So the sum of 2 squares doesn't break down, at least you can't factor it. But you can still set this equal to 0 and solve. Now, I guess you can do quadratic formula if you want to, but that's way more work than is really necessary. Ideally, just subtract the 4 over and take the square root of both sides. If the square root of 4 is 2, then the square root of negative 4 would be 2i. Now, when I started this question, I made 4 blanks because, again, I said that helps me catch some of my mistakes. Right now, I only have 3 zeros. So what did I forget to do that made me miss my 4th one? Right, when you take the square root of both sides, it's plus or minus. That's one of those things that I know you guys know, but you sometimes forget it. Yeah.
If we put like plus or minus 2, like in one blank.
Yeah, that's fine.
Okay.
I think the person who made this worksheet probably did 2 blanks for like plus or minus 2 and then plus or minus 2i, but I think that's probably where they were going with that. But in the end, 4 solutions because it's a 4th degree. That's all the fundamental theorem of algebra says. Okay, one more like this, and then we'll start to change the question types, even though we'll have a similar goal. So finding the zeros of this is asking where it equals 0. You can see we didn't give you a hint, and we're still saying no calculator right now, which means that it needs to factor. So you can get this with guess and check. Guess and check with the 4th degree is not any harder than guess and check with the quadratic. But if you really need to do the product sum method, the product sum method will still work. It'll split it up into 4 terms, and then you can do grouping with the 4 terms. But now on this one, I get x squared plus 8. I could set this factor equal to 0. He doesn't break down anymore, so I just have to solve him by hand. So quadratic formula, or just subtract the 8 over, take the square root of both sides, don't forget the plus or minus, and since the square root of 8 breaks down, we should break that down. That would be 2 square roots of 2. One of them's positive, one of them's negative, and because it was a negative 8, you need an I in there. Okay, and then do the same thing with this side. Quadratic formula, or just add the 6 over, take the square root of both sides, and as long as you're paying attention about how many answers you should have, if you forget the plus or minus part, then you should at least catch it before you're finished. Now, honestly, a calculator would not have helped much on this question, just looking at the answers, because remember, imaginary zeros don't show up as x-intercepts, so you're not going to see these on your graph anyway. These two would hit the x-axis, but I don't know, the square root of 6 is not a nice whole number, so you know, unless a rounded answer is okay, you're probably not going to see that decimal and say, oh yeah, that's just the square root of 6. So don't think a calculator could help you get these answers, but if you had a calculator, you could certainly check your answers. Just like I bugged you about in the last unit, you could store this in for x, type this in your calculator, hit enter, expect to see 0, store this one, do the same thing. You could check all 4 that way. So. Okay, so to me, 1, 2, and 3 are pretty similar. So before we kind of switch gears here, you guys okay with that? Anything you want to follow up on? Okay, then let's skip 4 for just a second, because 4 and 5 are the same type of question, but 4 is a harder version, a longer version. 5 is a little bit easier, but it's a lot of the same thought process, so I think it makes sense to start with this one. Okay, so we're still not giving you a calculator here, but what's different than questions 2 and 3 is that this doesn't factor. You could try to do factor by grouping, and it's just not going to work. Not everything factors. But instead, we're giving you a hint. So this is what kind of changes our approach to this question. X plus 4 is a factor. Now, I know this question says find the remaining factors, but I'm just going to list out all of them, because then I can emphasize again. 3rd degree means 3 zeros, which means 3 factors. And I know this question's not asking for it, but that's okay. It doesn't take but 2 more seconds to answer it both ways. So this one is telling you a factor, so indirectly telling you a 0. Where that equals 0 would be a 0. And then somehow we have to use this information to help us find the other 2. Any guesses on how we do that? Huh? Good. So that's why we did polynomial division yesterday, is because you either have to do long division by this or synthetic division by this. should be the same answer, so it doesn't matter, just whichever one you're more comfortable with. I tend to go with synthetic division just because it's faster for me. But so you need to know the setup and the algorithm. I'm not going to bug you too much about that. Okay, I'm going to do something here. 1428. Okay, how should you know that that's not correct? Because what? What does it mean to be a factor? If something's a factor, it means it divides into it evenly. We should have a remainder of 0. So I kind of fudged my arithmetic here. If I didn't get a remainder of 0, I know I did something wrong here. And I did it purposely today, but Wednesday, I went too fast and had an arithmetic mistake. So you would know to double check 1428 right here. This would be -5, so this would be +20. So if it's a factor that you're dividing out or a 0 that you're factoring out, it has to have a remainder of 0. So you've got a little bit of a check there. And just like we talked about yesterday, these 3 numbers now mean something else. They represent the degree lower. So we've got 6x squared, a -7x, and a -5. Now, even though I still have to do more work to find the last 2 factors and the last 2 zeros, what you need to appreciate is, just like question 1, if we know how to get it down to a quadratic, we at least have a plan on how to finish it. We always know that quadratic formula will work even if nothing else works. However, this one does factor. Again, guess and check. It's good to continue to practice, but if you have to do product sum or some other method, then please do. But if you were asked for the other factors, then there they are. If you were asked for the zeros, it would be where those 2 equal 0. So we have this idea that if, okay, go ahead.
So product sum, what multiplies to -30? Oh, never mind.
Okay. What I was going to say, and I don't necessarily have to go through the whole thing, but the thing I like about product sum is if you don't see that right away, you can just like step yourself into it. 1 and 30, one of them's negative, not going to add up to this. Make this a little bit bigger, which makes this a little bit smaller. Neither one of those would add up to that. Make this a little bit bigger, which makes this a little bit smaller. And then if you do it that way, you can kind of just walk yourself into it. You don't have to it doesn't have to be your first guess. Just start off with 1 and 30, and then 2 and 15, and then 3 and 10. And then it's a little bit more obvious. Okay, but we've got this big idea here where if we can find a 0 or a factor, or it's told to us, we can divide it out with synthetic division or long division, and as long as we can get it down to a quadratic, worst case is we could at least finish solving it with quadratic formula. Okay, so back to question 4, which is kind of the same thought process here, but a harder version of that question. This is a degree 4, so I'm going to do 4 blanks. I know it says remaining, but again, I just like to list them all. And this question, we give you one of them, and we got to come up with the other 3. Now, even if I divide this out, that's going to be crazy messy and not what I suggest you to do. But even if I divide this out, it only takes it from a 4th degree down to a 3rd degree. And I'm not any better at solving 3rd degrees than I am 4th degrees. We're great at solving quadratics, but anything bigger than that, we kind of have to work them out like this. So there must be another one that we're supposed to know. Do you remember what that might be? Well, opposite means negative. That's close, but not quite. Do you know what the other 0 would be?
The subtractive version, 2
2
minus 5.
minus I. There you go. So it sounds like you guys need to add this to your notes because this is something that you are expected to know. That imaginary zeros always come in conjugate pairs. Remember, conjugate just means you're switching that middle sign. So when you're told 2 plus I is a 0, indirectly you're also being told 2 minus I is a 0. And for this question, you had to know this. If I sidetrack for just a second, in questions 2 and 3, we also did it up here. It's just that you didn't need it to get the answers. One answer was 0 minus 2i, and one answer was 0 plus 2i. Imaginary zeros come in conjugate pairs. And then in question 3, 0 plus 2i squared root of 2 and 0 minus 2i squared root of 2, imaginary zeros always come in conjugate pairs. But you have to know that one to move forward. Without knowing that one, you're going to be pretty much stuck at the beginning. Okay, now the issue comes, like question 5, if I could divide this out, I could get it down to a 3rd degree, and then if I could divide this out, I could get it down to a 2nd degree. The problem is, with these two terms, and one of them being I, if you try to do synthetic division with this, I'm not even sure that that would work, but if it did work, it would be a nightmare. So instead, what we're going to do is we're going to think of these as factors. And I'm just going to list out all 4 factors while we're at it, because it doesn't take but a moment anyway. And to go from a 0 to a factor, you just do x minus the 0. And then you have to distribute the minus. Just like if 1 is a 0, that means x minus 1 is a factor. It's the thing that equals 0 at 1. So x minus a 0 gives you the factor. Now likewise, if I do long division by this, it's going to be really messy. And then I guess in theory, if I came back and then divided long division by this, it would be very messy until the very end. But what should happen is, when I divide these two out, I'm going to be left with some sort of quadratic that's going to give me the other 2 factors and the other 2 zeros. But since I don't really want to divide by these, a trick that we can use is we're just going to divide by both of these at the same time. And we're going to need this skill down on the next page anyway. So if you were to multiply these two things together, it's going to look a lot nicer, and then we'll divide that out. It'll be the same thing. So we need to distribute x to all 3 of these, which gives us 3 terms. Then distribute negative 2 to all 3 of these, gives us another 3 terms. And then distribute negative I to all 3 of these, which gives us another 3 terms. 3 terms times 3 terms should give you 9 terms.
So x times I is x?
X times I is xi. And that doesn't look much better, but then if you're paying attention to the terms that combine, we have a plus xi minus xi that adds to 0. We've got a plus 2i minus 2i that adds to 0. So we've got an x squared minus 2x, which makes minus 4x. And then there's a way to combine these as well, but I don't think this has come up for us this year. So what I have told you is I is the square root of negative 1. So if I square both of these sides, square the left side, I get I squared. Square the right side, I get negative 1. I squared is negative 1. So right here, this guy is like saying minus a negative 1, which is really just the same thing as saying plus 1. That's why you can combine it to the plus 4 and end up with the plus 5. So what I'm doing here is I'm taking these 2 factors that look really unfamiliar, multiplying them together, And then these two things are saying the same thing. These two things are equal. This is very messy, temporarily messy, but then it combines together to a nice looking quadratic. So now I can divide out these two factors given to me from the beginning. And as much as I would love to, as much as I'd love to do synthetic division, cannot synthetically divide by a quadratic like that. So we're going to have to do long division. But like we talked about earlier, if these are coming from factors, and a factor means it goes into it evenly, unlike yesterday, I at least know that at the end I should have a remainder of 0. I've got a bit of a check. So if we start going through the long division process, the first part needs to be x squared, because x squared times x squared gives you x to the 4th. Multiply it by this. Multiply it by this. Change the signs and add. Start the algorithm over again. Looks like the next piece would be -4. Change the signs and add, and confirm that you got the remainder of 0 that we knew was supposed to happen. Okay, so big picture, why did I do this? What was the purpose of this? Okay, so I took my 4th degree, I divided out two factors, x squared, and what I just exposed was this hidden quadratic that I couldn't see from the beginning, but I can factor it as the difference of two squares now. I can see it clearly, and where this equals 0 and where that equals 0 gives me the other zeros. So it's messy for a bit, but everything does kind of work out nicely in the end. So just quick recap. We gave you 1, 0 because it was imaginary. It's guaranteed that its conjugate was also a 0. You should know that you need to divide these out to get it from a 4th degree down to a 2nd degree. But realistically, even though it looks like a lot of work, you really want to think of these two as factors, multiply those factors together to see what kind of quadratic it makes. Divide by that quadratic as a way to just divide them out both at the same time. Since they're factors, it goes into it evenly, and then what's left over is like that hidden quadratic that I knew was in there that I just couldn't see, and from that I got my last two factors and my last two zeros. Now, I'm sure that this is not going to be your favorite question type, just because it is more difficult than a longer question type. But you do hopefully at least appreciate how it shows you all this stuff is important. Like, I'm sure you practice stuff like this in Algebra 2, and we're going to do one on the next page. It shows you where long division could show up in a question that's not just, hey, do long division. It shows you why you might need to know imaginary zeros come in conjugate pairs. Shows you where I squared being -1 might show up. It really does a good job of pulling together a lot of otherwise seemingly random algebra skills. Okay, so let's skip to 6 and 7, and then we can move on to the book work. So 6 is like working one of these questions backwards, and then 7 is really not any different. It's just making sure you're familiar with those directions. So by working this backwards, what I mean is, instead of us telling you what the function is and you go find the zeros, we tell you what the zeros are and you got to come up with the function. And probably not that you care, but this is what we have to do when we make tests. Like, we don't just pick random functions, work them out, and see if the answers and the work is realistic. We start with the answers, and then we do this process, and then we come up with the function, and then that's what we would do for a test. So if I change these zeros into factors by doing x minus and distribute, If I multiply these two together, I'm only going to end up with a quadratic. So why does it say third degree polynomial?
You have to have your conjugate of the
Right, so once again, imaginary zeros always come in conjugate pairs. And that's not just a Fayetteville High School thing. You'll see in the book, they do the same thing to you. They'll give you one and expect you to know the other. So now we have factored form, and if the question said factored form, we'd be finished, which is kind of what we're going to do in question 7, or what our answer is going to look like. But this one actually wants us to multiply them together, so in the end we have real number coefficients. So in theory you can multiply these together in any order you want to, but I would suggest you multiply these two together first. So this is similar to what we just did on question 4. Do x times all three of these. That's going to give you 3 terms. Then distribute -6 to all three of these for another 3 terms. And then finally I to all three of these for another 3 terms. 3 terms times 3 terms should give you 9 terms. Trying to do that in 3 different colors there so you can see where all 9 are coming from. Also, like on question 4, most of this is going to add up and clean up very quickly. So plus xi minus xi plus 6i minus 6i, a lot of it goes to 0. You do have an x squared that has no one to combine with. You've got a minus 6x that makes a minus 12x. And then right here, this combines with the plus 36 and gives us 35, 36, 37,
37.
gives us 37. Good. If I squared is -1, this is like minus a -1, which is like plus 1. So just like in question 4, it looks really scary for a second, but then it all kind of comes together. Alright, and then to finish up, now we need to multiply in this x minus 1. So do x times all three of these. And then -1 times all three of these. And then if we combine like terms, we should have our answer. Oh, oh. It's 37 x's and a minus 37. Okay. I think that's okay, but so one good sign, looking at my answer, is it said it was supposed to be a 3rd degree, and in the end I end up with a 3rd degree. You won't always have a calculator, but if I was to graph this, looking at those zeros, if you have a 0 of 1, 6 plus I, and 6 minus I,
Why is it 24x squared? Because when you distribute your -1, what should you
yeah, right here, this should have been minus 12x, right? Yeah, I knew, I could feel that something was off, but I couldn't see what it was.
Plus 12x?
Huh?
Is it, it's minus 12x?
Should be plus 12x?
Plus 12x.
Okay, so then plus 49x. Okay, does that look better? Okay, well, what I was about to say, I was about to check it anyway. So, just like with quadratics, you need to remember that imaginary zeros You're not going to see them on a graph. Nowhere on the graph is there a spot for 6 plus I and 6 minus I. But real zeros, like the 1, should show up where on the graph? On the x-axis. So if we graph this, the only x-intercept should be 1, because 1 was the only real zero. Imaginary zeros don't show up, real zeros do show up as x-intercepts. So if I had not caught that arithmetic, I was about to catch it, because it wasn't going to have an x-intercept of 1 unless it was extremely big coincidence. So backwards, instead of starting with this and you finding those, we're giving you these. Change them into factors by doing x minus each one. Multiply them together, combine like terms, and then you get the answer. Okay, and then 7, again, it's not much different. It just really, the thing that throws students off on this, and we usually do put this on the test, is students don't remember what these directions mean. So first off, it says factors. So it needs to look like it's factored. It wants it to be product. Product means multiply. So we're not going to separate the products with, we're not going to set the factors, separate them with commas. We're going to multiply them. And they need to be linear. Linear means your exponents on x should be 1. So if we first find the zeros, again, this question doesn't say anything about using a calculator, and there's no hint on this one. So just like the front page, that means it probably should factor. And then you could set this equal to 0 and solve, get a couple zeros. You could set this equal to 0 and solve, get a couple zeros. And the way you turn a 0 into a factor is by doing x minus the 0. And then x minus the next one, x minus the next one, x minus the next one. So just, it's being picky about how to write the answer. Product, multiply them together, factors, and linear factors. So this right here, this would not work as the final answer because these are quadratic factors. These are linear factors. So to me, that's way easier than some of those other questions. But I will tell you that that is often a point, or points that students miss on the test because of these directions. So you might want to write yourself a note there and highlight that just so that hopefully it doesn't affect you. Okay, make sure you get that copied down, and then we need to slide over to the book assignment. And again, I said there was one thing. I'm sorry, did everyone have that copied down? Okay. There is one thing that comes up in the book work that you guys normally talk about in Algebra 2 that it seems like you may not have last year. So I'm going to work with you here on the first few. And then I will give you some time to try to finish the rest. So your blank piece of paper that you guys got out this morning, go ahead and copy those 11 questions down, and then go and do the first 2, please. The first 2 questions should take you about 5 seconds each. Should be very fast questions. And then I will come back and check those with you, and then we will look at question 15 together. That's what I think you may not have seen. Okay, so the reason I said the first two should be very quick is because all it asks is how many zeros should it have. So number 9 has how many zeros? 3, because it's a degree 3. And then number 13, there's 2 zeros. Be careful because of this square. If you need to do this times itself and FOIL it out to see that a little bit clearer, then please do. But it is a quadratic, so 2 zeros. Okay, and then 15 talks about something called the rational zero test. And I don't know, most of my classes, I don't think there was anybody who thought that this was familiar. But it's really easy to do. It's a little bit harder to understand what it means. But we'll talk about both of these. I'm just kind of surprised y'all may not have seen it in Algebra 2 because I know it used to show up on the ACT. So the rational zero test a lot of times people know this as the P over Q list. I don't know why they use letters P and Q. But the way we're going to get our answer, again, the answer is not too hard, is we're going to take plus or minus all the factors of P and divide it by plus or minus all the factors of Q. So that implies you need to know what P and Q are. So P is the constant and Q is the leading coefficient. So for question 15, P is -2 and Q is 1. Now even though P is negative, that doesn't really matter because we're going to do plus or minus anyway. So by factors, I mean things that divide into it evenly. So the only things that divide into 2 evenly are 1 and 2, and we're going to do plus or minus each of those. Then divide it by plus or minus all the factors of Q, and Q is the leading coefficient, so that would be 1, plus or minus all of that. So this is what it would look like on the ACT. And you're probably going to recognize it if you ever see it because all of the answers look like that. Now, I normally don't go ahead and break it down, but I think it will help you understand what it is we're describing here, and then we can look back at their graph for the answer here. What the rational zero test tells you is the possible, and I can't stress that word enough, possible rational zeros. So it's not going to help us find irrational zeros like the square root of 6. It's not going to help us find imaginary zeros like I. But everything in this list is a possible rational zero. So really, if you took any of these in the numerator over any of these in the denominator, so like 1 over 1, negative 1 over 1, 2 over 1, negative 2 over 1, and the rest are duplicates. So these are saying the same thing. These are the possible zeros. How should you know that these are not all of its zeros? Something about this that make, like, if it said find the zeros, how could this not be the answer? Right. This is a third degree. There's only 3 zeros, so there's no way all of these are zeros. But the connection they want you to make is, if you look at the graph they provided, it looks like it has a 0 at 1, which was in our list, -1, which was in our list, and -2, which was in our list. So the rational zero test doesn't really help you tell you what the zeros are, but it tells you what they're not. Like, for example, 5 is not in this list, so I know without looking at this graph there's no way there's an x-intercept of 5. 3 is not in this list, so there's no chance that 3 is a 0. There's no chance that 3 is an x-intercept. These were the only ones that were nice whole numbers that we could have expected. And it turns out that those 3 were the ones that were there. So 16 is the same type, so if you would try that one, and we will go over it to make sure you're okay with that. And then I need to do one more with you, and then I'll give you some time to try the last few and see how they go. Okay, let's make sure your work is okay in 16. So again, to find the possible rational zeros or to use the rational zero test, same thing. It honestly doesn't take but about 20 seconds if you know exactly what you're looking for. It's the P over Q list. You have to know P is the constant, Q is the leading coefficient, plus or minus all the factors of Q. So everything that divides into 16 evenly over plus or minus all the factors of Q. So that is the answer to the question. Those are the rational numbers that it might be zeros for this function. Just like I said in the last one, 3 is not in this list, so there's no chance that 3 is a 0. 7's not in this list, there's no chance that 7 is a 0. Obviously these are not the real zeros because it only has 3 zeros and there's like 10 different things there. But what they want you to see is that if a 0 is a rational number, it has to be in this list. So that's why they gave you the graph. 4 was a 0, 4 over 1 was in the list. 2 was a 0, 2 over 1 was in the list. Negative 2 over 1 also in the list. So the rational zeros were in that list. So again, it's not good enough to be like, here are your zeros, but it does like limit it down from, I guess, an infinite number of numbers to at least just a handful of numbers. And of course, this is not going to list any imaginary zeros, and it's not going to list any irrational zeros, but it can help us with some. But the stuff that's highlighted here, if you are trying to improve your ACT score, that might be something that you put to the side for a separate sheet of paper, because unless something's changed, that used to show up on the ACT sometimes, and it's not a hard or long question, so you could certainly get those points. Okay, any questions y'all want to ask about that? Okay, I'd like to do one more with you. What is the next one? 20, 30? 31? It is similar to what we did on your notes, but actually just a touch easier, but it will seem a little different at first. Okay, so we've got a polynomial. It's asking us to find the real solutions. I know it can have at most 4. I know it's going to have 4 zeros. I don't know if they're all real zeros, but I'm going to make 4 blanks to aim for. So some of the questions we saw in our notes would factor. This guy's not going to factor. The first question we looked at was quadratic, and we just used quadratic formula, but you can't use quadratic formula if it's not a quadratic, so that's not available. Some of the questions we looked at gave us a hint by telling us what a zero was or what a factor was. That is not in our directions. But on this one, what is going to be different is we are going to use a calculator. So I'm going to graph this in my calculator, and it is going to give us a hint on how to move forward. It's not going to do it for us. Well, sometimes it will do it for us. It really just kind of depends on the function. So here's what it looks like. It said find all the real zeros, and now that we have the graph in front of us, how many real zeros does this have? It does have 4 because they're x-intercepts. Remember, real zeros show up as x-intercepts. So you might think, well, wait, I'm about 10 seconds away from having all 4 answers, and unfortunately, sometimes that's true, not true in this one. So looking at these x-intercepts, what would you guess one of them might be? Okay. So it does look like it's going through 1, but we shouldn't assume that. So here's how you guys can check. If you do trace 1 enter, your calculator jumps to that point, and then it confirms for us down here when x is 1, y is 0. So that is great. 1 is one of our zeros. What's another one you think you might know? Negative what? Okay, so trace -3 enter is exactly a 0. -3, 0. So there's the second one. Okay, what about this one? What do you think it might be? Okay, so 1/2 is a good guess. Huh? Is that not what I said? 1/2? Okay, but if you assume that, you're going to be wrong. If you do trace 1/2 enter, when x is 1/2, y is not quite 0. So it was close, but not 1/2. Likewise over here, I think if you had to guess, most of you might pick like -4.5. If you do trace -4.5 enter, y is not 0 there. So these might be some weird decimal that, I don't know, maybe it's 1/3, maybe it's 2/3, maybe I could guess it eventually, I don't know. But it might be something that I would never guess. So our calculator has outlived its usefulness. So how in the world are we supposed to get the last 2? Very good. If we divide out one of these, we can get it from a 4th degree to a 3rd degree. But truth be told, I'm no better at solving 3rd degrees than I am at solving 4th degrees. The good news is we know a second one, -3. Now, don't divide -3 into the original one, because that's just going to turn it into a 3rd degree. divide -3 into the reduced one. And by the way, these are both zeros, so both of these should have a remainder of 0. We've got a little bit of a check that we don't always have. And then what do these 4 numbers represent? We got 1, 1 what? It's an x squared. We start off with the 4th degree. When divided out 1, this represented x to the 3rd. So if we divided out another one, this now represents an x squared. So the next one would be x, and the last one would be the constant. And again, this is not my favorite either, but we should at least feel at ease now because we are on our way. Quadratic, I would love for this to factor, but honestly, if it factored, those x-intercepts would probably be nicer looking. But I can do quadratic formula. So square root of 24. Which is 2 square root of 6. All of those divide evenly by 2, so we end up with -2 plus the square root of 6 and -2 minus the square root of 6. No, I know it looked like 1/2, but you were never going to guess that that was -2 plus the square root of 6. But with polynomial division and dividing out 2 of them that we were sure about, we were able to discover the 2 that were harder to see, the 2 that we wouldn't get from a graph. Now, while I have this still in my graph, it's important that you guys know that you could quickly check these as well. You can check all of this at the end and not just the storing. I mean, you could store this in your calculator and make sure that this equals 0, but since I have the graph, let's just look at it. If I think -2 plus the square root of 6 is an answer, do trace -2 plus the square root of 6, enter, and it jumps to that point. That x value is not close to being an x-intercept, it's exactly an x-intercept. So I can confirm that with the graph. And then -2 minus the square root of 6, trace -2 minus the square root of 6, enter, and it will jump to that point. And for that x value, we get exactly a y-intercept, which is what we are looking for, because that's what a 0 is. So even when it's weird decimals like that, your calculator is not going to help tell you what those are, but once you figure them out by hand, it does do a pretty good job of helping you check them. Okay, so what I do know you guys did in Algebra 2, I know you did some synthetic division, I know you did some quadratic formula. Did y'all ever like use some of these to divide them out and reduce it down to a quadratic? No? You don't remember that? Okay. Alright, well your next one on your homework is similar to that one, but it is quite a bit shorter, quite a bit easier. But you should start off with the calculator to get some answers. Hope that your calculator gives you all 3 of them, but even if it gives you just 1 of them, you could divide it out and find the other 2 with quadratic formula. And so I would like you to try that. And then 33 and 37 are similar question types. They do have a couple parts to them, but we have talked about all those parts today, so you need to try them on your own first. 41 and 43, we did one of those in your notes, so I think you can try that before you know if you need help. And then same with 59 and 60. They're the same type, but I would like you to try them before you ask for help here. And you guys have about 23 minutes to try the rest of those questions. If you don't finish those in class, then please finish those up for homework. Just to be clear, our quiz on this section is not next class. It will be the class after. And one thing we will do next Tuesday is I will go over these last few questions that you're finishing up right now.